So good morning and welcome back to this new week. It's the third week of May. In this week we are showing and prepare the new course, this new webinar. This webinar is focused on logging for hydrogen storage. Is an advanced technique, is new phase to explore, and so generally when we talk about to hydrogen, we talk about not only to green or gray hydrogen, but we talked about also to the white hydrogen. And white hydrogen is also a natural hydrogen that is formed in porous reservoir formation. And in this case we are talking about the porous reservoir formation. So when we are talking to the seal and to the storage of hydrogen storage, we are talking about to the sensitive with different log techniques. So instead of this, we are talking with the logging for hydrogen condition. And so we have possible to distinguish these two kinds. For example, logging for hydrogen detection and also logging for hydrogen storage. Start from the first phase. Logging from hydrogen detection is for the exploration of rocks and likes. Especially serpentinite rocks that can be contained this kind of rocks and this kind of hydrogen, and show you that it's possible to analyze and check this value. Neutron logs sensitive to hydrogen atoms used to estimate hydrogen index. For example, the neutron logs cannot. This is the list of tools that can be used by also Slumberger in hydrogen exploration. We have the neutron logs, it is common loggings, and sensitive hydrogen atoms used to estimate hydrogen index cannot difference between water, oil, and hydrogen directly, needs calibration. Pulsed neutron logs detected hydrogen in a rich zone can be estimated gas saturation in time lapse, and most challenge in this case for pulsed neutron logs is leave the high uncertainty in dry formation. It's clear that serpentinite rocks can be in high uncertain formation. Nuclear magnetic resonance measure hydrogen for relaxation time. This is the best technique to underline the presence of hydrogen because hydrogen is very sensitive to magnetic first speed of inversion speed is very sensitive to this kind, and can detect free hydrogen gas. So we have also is the best technique because we can detect easily the presence of free hydrogen gas, and so is the principal techniques to use in hydrogen exploration, but can be have some mistakes, but in total percentage of an estimation of total volume of hydrogen gas affected by the effect of pressure and temperature. So resistivity logs, we have this kind LLD, LSS, identify gas burning zone, hydrogen gas flower conductivity. And so we have also the interpretation need with caution unique results. Dielectric logs differentiate between waters and gas based on dielectric constant. Potential useful for hydrogen detection is calibrated. other techniques just in phase of testing, not just in phasing of structure. We had the detect of hydrogen in drilling, during drilling. This is gas chromatography, is a mud logs technique during drilling, is high sensitive techniques during drilling to detect the presence of hydrogen gas and produce gas on at surface. Surface model mass spectrometry is another technique linked to logging while drilling and measuring while drilling. Is detect the trace of hydrogen during drilling and early detection, but needs interpretation models. So it's clear that you have this kind of techniques, and we have also temperature. This is the principal technique. You need to remember magnetic, nuclear magnetic resonance, resistivity logs, and gas chromatography. This is the first tool during exploration, and this is the second tool during the drilling geophysical exploration, and this is the second tool during the drilling exploration. So this scheme represents which can be the situation, for example, a condition, a typical condition around the ground gas storage, the challenge, for example, the solution of hydrogen in salt aquifer, or is an example of can be capture and storage the hydrogen. Other log techniques for the storage. This is the first that I show you, is principal linked to exploration of natural hydrogen resource. So that is just called white hydrogen. Logging for hydrogen storage monitoring. Temperature logs, logging techniques for hydrogen storage monitoring. When we are talking about hydrogen storage, we are talking to a complex project to capture and separate the hydrogen from, for example, from water or from air, and storage in natural reservoir. So in this case, we are to monitoring the temperature, the pressure gradient, detect the thermally included the effects of hydrogen in action, confirm reservoir sagging, and detect leakage. Casing inspection logs. So we are talking about in casing inspection logs, evaluate well integrity, casing corrosion, and is crucial in cycling storage. Cement bond logs. We are also to evaluate the sealing integrity of being casing. So it's not so very important, but it is important. Acoustic logs is most important to detect the change information and establish the elastic properties during the gas in action. So it's the principal log techniques using in this case to evaluate the principal type of this case. Fiber optic sensing, distributed sensing of temperature, acoustic for real-time monitoring. It's clear that in this case we have a typical detect change information elastic properties. So the acoustic log is the principal log using during storage hydrogen. And also we have the fiber optic sense for long time monitoring. We are also monitoring the temperature and acoustic real time with high resolution, and we can detect the anomalies in pressure and also in compression of volume like this. But the principal is the acoustic logs. Thanks for attention. So this week we are coming to complete petrophysical course about logging storage. So, thanks for attention and coming in for the next appointment on Saturday.